This video is over topic 24, numbers 3 through 6, doing normal distribution word problems. So when you get these questions, you're going to be given a mean, you're going to be given a standard deviation, you're going to be given one or more data values along with information you're looking for, a percentage usually on these, that are longer, that are shorter, bigger, smaller, taller, wider, or that are between these two. So you have to pay attention to the words, but the process, when you have the use this table, if you're going to use this table, what do you have to have? You have to have the z-score. The z-score gives you the area. The area is the decimal form of the percentage. But you may have to combine those areas or percentages in some way or otherwise adjust to correctly answer the question. So you're going to find a z-score. You're then going to look up the z-score, find the area, and make sure that you do the right thing with the area to answer the question that was asked. Draw a picture of the little normal curve. That helps. So first example here, number 3, we have the average American sends 872 pounds of garbage. That's the average. So that's my mean. To a landfill each year, normally distributed with a standard deviation of 160. That's my standard deviation. Says use the z-score table. Find the percentage of people who send more than 1,000 pounds. 1,000 pounds is my data value. I'll call that X. And I want more. So I'm going to draw a little picture here. The mean here is 872. 1,000 would be over here somewhere. And I want more than 1,000. So this is what I'm looking for. First step, I have to find the z-score. Data value minus the mean divided by the standard deviation. So that's 1,000 minus 872 divided by 160, 0.8. Oh, that is my z. If I look up the area on the table, again, that's the area to the left, always. So I'm going to bring up the table, find my 0.8 on the table. That would be 0.80. If you need extra digits, add zeros at the end, not between. So 0.80 here would be 0.7881 for the area. So that's over here is 0.7881 or 78.81%. That is not what I've been asked for. I need this. So I can either take 1 minus 0.7881 or 100 minus 78.81% if I want to do it in percent form. Or I could look up negative 0.80, and that will give me directly what I would get from subtracting 0.2219. Sorry, 2119. Look down. 2119. So either way, it's 21.19%. Next example, the length of human pregnancies is approximately normally distributed with a mean of 266 days, standard deviation of 16 days. And we're looking for what percentage of births occur within 1 week before or after, or that is what percentage of pregnancies last between 273 and 287 days. So for a between, I need to take an area minus an area. For each area, I need a z-score. So the z-scores, and it's the higher number is going to be the higher area. So I'll start with that. So 287 minus 266 divided by 16. And this one's going to be 273 minus 266 divided by 16. And we get 1.3125 and 0.4375. I'm going to round those to 2 decimal places. So my z-scores, I'm just going to, so that would be 1.31. This would be 0.44. So I'm going to look each of those up. 1.31, 0.9049, 0.44, 0.6700. If you use the ALEKS calculator, if you put in the 1.3125, then you see it comes out a little different. It'd be 9053. Only if you use the 0.4375, 6691 rather than 6700. I am not sure whether ALEKS will accept those or not. Those would be more accurate, so I would think that it would, but it might not. So just be careful with that. If you're using the ALEKS calculator, sort of experiment with it, see what it accepts. But it may want you to just use what's on the table. This would be 0.9049 minus 0.6700, or you could do it in percent form. Either way ends up in decimal form 0.2349, which gives the percentage 23.49% for the final answer. All right, a tire model has an average life of 41,000 miles, so that's the mean. Standard deviation of 3,900. We're looking for what percent will need to be replaced before reaching 50,000. So looking for the percent that go less than 50,000. So don't need to do any extra work. Just find the z-score, look it up, convert to percent form. So z is 50,000 minus 41,000 divided by 3,900. That's 2.31 when I round to 2 decimal places. I round to 2 decimal places because that's what I have on the table. So I go on my table, I find my Z 2.31. Here it is. Area is 0.9896. That's the less, the ones that are before 50,000. So that's the area that I want. It's 98.96%. Almost all will not reach 50,000. A few, less than 2%, barely over 1%, would then last beyond 50,000 miles. And then one more example, we have a roller coaster that restricts height in both directions. You can't be too short or too tall. So we're looking for, we have the heights of adult women normally distributed. We have the mean standard deviation. We're looking for the percentage of adult women that would be disqualified from riding. They're either too short or too tall. So first thing I got to do is find the z-score for each of those data values. So for the 60 inches and the 72 inches. Those are like my X values. So 60 minus 63.8 divided by 2.8. And then I'll have 72 minus 63.8 divided by 2.8. So let me do those calculations. 63.8 equals divided by 2.8 equals negative 1.36. And then 72 minus 63.8 equals 8.2, and divided by 2.8, 2.93. So those are my z-scores. Now, for the 60, I want the ones that are below that. So I don't have to do anything fancy with that one. I just look up the negative 1.36, 0.0869. So this, 8.69%. For the 2.93, when I look up 2.93 and get 0.9983, that's telling me this whole area. So all of this is 0.9983 or 99.83%. So there's a couple ways I can do this. One, I can take one, that's the area to the left, area to the right is 1 minus 0.9983. I can also look up negative 2.93 because the area to the right of positive 2.93 is the same as the area to the left of negative 2.93. So that's 0.0017. I could also say, all right, what I actually want over here is all except this middle part, which is the between. So I could say between the ones that are allowed, I subtract the 0.9983, so this whole area, minus the 0.0869. And get, that would be 0.9114. And I want all that are not allowed. So that would be 1 minus 0.9114. Again, any of these additions, subtractions can be done in percent form. But I also, like I found, this is 8.69%, and this over here is the 0.17%. So let's confirm that these all come out the same. 100 minus 91.14 or 8.69 plus 0.17, either way, 8.86%. So don't do all of those things. Figure out one of those that makes sense that you can get the 8.86% and use that method. So that is z-score normal distribution word problems.